Hello everyone, welcome to Mathematics with Shahab Yaqub. We are starting with lecture number 3 of coordinate geometry. So what have we discussed in coordinate geometry so far? In the last class, we talked about equation of the line, and before that, we talked about the slope, the inclination, the gradient of the line. So let's carry the journey forward and let's focus a little bit more on the gradient. First of all, we'll be talking about parallel lines. Now, first of all, what are parallel lines? Let's say this is one line and then this is the other one. So now this line, let's call it L1. Let's call this line as L2. They are parallel. How do I know that they are parallel? The perpendicular distance between them remains the same. So first of all, what is parallel lines? The perpendicular, that is the symbol that I use for perpendicular. Instead of writing it all the time, I use this symbol. So in parallel lines, the perpendicular distance remains the same. The perpendicular distance between them, that is the whole sentence. The perpendicular distance between the lines, and let me shift this thing down and let me shift this thing up. So now it looks good. The perpendicular distance between the lines remains the same. So that is one way of explaining this. Similarly, parallel lines, they never meet. Some say they meet at infinity, but who has seen infinity? So now this is one line, this is the other line, they are parallel. That is the first conceptual thing. The gradient of line 1 is M1, the gradient of line 2 is M2. If two lines are parallel, let me highlight this. So if two lines are parallel, they have the same slope, they have the same gradient. That is the thing by which we will judge if two lines are parallel. For example, if I have y is equals to 2x, if I have y is equals to 2x minus 1, if I have y is equals to 2x plus 5. So let's say this is line 3, this is line 4, this is line 5. They all are in the standard form, the gold standard, which is y is equals to mx plus c for a straight line, for a linear equation. Increase your vocabulary because the examiner could be asking these things in any which way. So the coefficient of x is 2, the coefficient of x is 2, the coefficient of x is 2. So therefore the gradient, let me first write the gradient. Gradient 3 is 2. So is gradient 4. So is gradient 5. Therefore, what should I say? I'll say line 3 is parallel. Let me use the symbol for parallel to line 4, which is parallel to line 5. That is how we will judge. But first of all, it has to be in the standard form. The coefficient of y should be 1. It should be on the left hand side, and coefficient and the x term should be on the right hand side, and the coefficient of x, that is the slope. So that is the basic knowledge that we need. Again, and a worked example right over here. Lines that are parallel have the same gradient. Example 1. Which of the following line is parallel to this line? Now, what is the trick? That first of all, we have to write in the standard form. So keep y on the left hand side and take 2x on the other side. So therefore, this is negative 2x plus 5. And now the gradient of this line, the coefficient of x is negative 2. So what do we have to check? We have to check whether this line or this line or this line, are they having the same slope as this one? First of all, it's already in the standard form. So part A, let me rearrange it a bit. Y is equals to minus 2x plus 3. And part B, let me also arrange it. Y is equals to minus x plus 5. And part C, y is equals to 2x plus 6. So over here, the gradient is negative 2. Over here, the gradient is negative 1. Over here, the gradient is plus 2. Since only this has a gradient of -2. Therefore, only this line which they have not labeled, let me label it according to the part. Line A is parallel to which line? That line is y is equals to -2x plus 5. This is not parallel. This is not parallel. Why? The gradient is not the same. Now just go through this exactly. I'll just have the recording on so you can comfortably watch. I'll simply point it out. So basically, it's about rearrangement of the form y is equals to mx plus c, and then we'll just focus on the coefficient of x. So that's how we will know that the lines are parallel. Now, another type of question, and which is very, very common, that is, find the equation of line L which passes through this point and is parallel to this one. So what is step number 1? Step number 1 is write the equation of the line in the gold standard, which is y is equals to mx plus c. It's already in the gold standard. Y is equals to 3x plus 2. Therefore, the coefficient of x is m. The coefficient of x is 3. Comparing coefficient, we get m is equals to 3. So let me write also over here, compare coefficient with gold standard. Now, since the lines are parallel, step 2, lines are parallel, therefore the equation of the other line is also 3, and therefore excuse me, the last part, that is, it's passing through the point 5 comma 8. So I have 5 comma 8, I have the gradient 3. Let me write the equation y is equals to mx plus c. First insert 3, y is equals to 3x plus c. All good, everyone is following. Now plug in x is 5, y is 8. So instead of y, I'll write 8. Instead of x, I'll write 5 plus c. This is 8, this is 15, this is c. Therefore, 8 minus 15 is -7, that is c. And hence, the final answer, the equation of a line y is equals to 3x minus 7. Let me double check, and that is the equation. Again, have a good look at what exactly have I done. All good, all clear? So these are the 3 steps that we will use. Now that's the exercise. I have marked these equations, these questions. Write down the equation of 3 lines that are parallel to this. So as long as the gradient is the same, I can write y is equals to 5x, y is equals to 5x plus 1, y is equals to 5x minus 2. All these lines, I can write numerous of them. Since all these lines are parallel, they have the same gradient, the y-intercept can change. The y-intercept could be 0, the y-intercept could be 1, the y-intercept could be -2, and so on. Similarly, another check thing, that which of the lines are parallel, just like our worked example 1. Now, which of the lines listed below is parallel to the line shown in the diagram? So what should I do? Let me choose this point. This is 0, 2. And let me choose this point, which is 3, 1. Let me evaluate the gradient. Draw the arrow. So therefore, this is 2 minus 1 over 0 minus 3. 2 minus 1 is 1. 0 minus 3 is -3. This comes out to be -1/3. Now, what should I do? Let me write all these equations in the standard form. Part A, y is equals to -3x plus 2. Part B, 3y is equals to 7 minus x. In other words, y is equals to 7 over 3 minus x over 3. And part C, y is equals to 4 minus 3x. Part D, 3y is equals to x plus 8. Therefore, y is equals to x over 3 plus 8 over 3. No need to go in decimals. Always work in fractions. So let me write this down. Always work in fractions, because fractions are beautiful. Fractions are exact. There is no rounding off. And this is something that you will use a lot in O-level maths also, but even much more in A-level maths. What else is there? Part E. Now let me write part E. Y is equals to 3 minus 1/3 x. And part F, 6y is minus 2x. 6y is negative 2x. Therefore, y is negative 2x over 6, which can be written as minus 1/3 x. Now, I'm looking for a gradient which is minus 1/3. This is not. This is minus 1/3. This one is positive 1/3. This one is minus 1/3. This one is minus 1/3. So, part F, part E, and part B. These lines are parallel to the given line in the diagram. And question number 4 is just like what we have done. Find the equation of the line which is parallel to the given line. Equation of the line which is parallel to the given line and passes through the given point. Give your answer in the gold standard. Y is equals to mx plus c. So I'll just try out one of them, which is part H. So let me write it down. So this is part H. Y is equals to 7 minus 9x. It passes through the point 1 comma negative 11. So first of all, is it in the standard form? Almost. You can just do a bit of what you call manipulation, arrangement. Write the x term first and then the constant. I mean, it just looks better and nothing more. Y is equals to mx plus c. The coefficient of x is m. The coefficient of x is negative 9. Therefore, m comes out to be negative 9. So now we have these 2 points and these point with this x coordinate, this y coordinate, this gradient. So now step number 2, y is equals to mx plus c, y equals to minus 9x plus c. Now plug in x is 1, y is minus 11. And this is negative 9 into 1 plus c. Negative 11 is minus 9 plus c. Negative 11 plus 9 is equals to c. Therefore, c comes out to be negative 2. So we have c, we have m. Therefore, the equation of a line is y is equals to minus 9x minus 2. And that is of the form y is equals to mx plus c, which is our gold standard. So this thing is all good, all done. So now let's move to perpendicular lines. So parallel line is one thing, perpendicular line is the other. Now let's say one line is going like this, and let me draw a green line like this. The diagram is not drawn to scale, first of all, so just don't take out your protractor and start measuring it. There is a 90-degree angle between the two. This is line 1, this is line 2. So now the gradient of line 1 is denoted as m1. The gradient of line 2 is denoted as m2. The rule says these two gradient will multiply to give you negative 1 if we are talking about perpendicular lines. So let me highlight this. It goes like this. So if the lines are perpendicular, their gradients multiply to give you negative 1. For example, let me write L1. Let me write the equation. Already in the standard form, y is equals to 2x plus 3. L2, y is equals to negative half x plus 5. Now I need to check whether these two lines are perpendicular or not. Yes or no. Now the gradient over here is positive 2. The gradient over here is negative half. So 2 into negative half, if I multiply, I get negative 1, which is fulfilling this criteria. Yes, they are perpendicular lines. That's how you will judge. Let me give you another example. line 1. Let me write the equation. Y is equals to negative 4 over 3x plus 7. And line 2, y is equals to positive 3 over 4x minus 5. Again, I need to check whether they are perpendicular, yes or no. Now, first of all, the gradient is minus 4/3. So let me just highlight this. Why is it not writing? Okay, let me just use this. So this gradient is negative 4/3. This gradient is positive 3/4. So therefore, I'll write negative 4/3 multiplying with positive 3/4. What does it become? It's very obvious. The 4 and the 4 will cancel out. It's very obvious. The 3 and the 3 cancel out, leaving behind a negative 1. Yes, again, these two lines are perpendicular lines. That is how we will judge. The product of the two gradient gives you negative 1. So let me highlight this and let me write over here. The product of two slopes is negative 1 for perpendicular lines. That is the knowledge that is needed. Now, before that, before some worked example, let me add a page. And that page is, so I can also say M1 is negative reciprocal of M2. The slopes, the gradients are negative reciprocal of one another. Reciprocal of one another. All good, all clear? So now let's say if M2 and M1, let's say I'm giving you M2, let's say minus 3, positive 4, negative 5 over 7, positive 3 over 2, something like this. So what will I do? I'll flip it. So reciprocal means flip it and change sign. Flip it and change sign. Why? Because it's a negative reciprocal. So this negative will become positive, this positive will become negative, this negative will become positive, and positive will become negative. That's the first thing. And the second thing is about flipping. So 3 becomes 1/3, 4 becomes 1/4, 5 over 7 becomes 7 over 5, 3 over 2 becomes 2 over 3. So that is how we will use it. Remember, in parallel lines, the gradients are the same. In perpendicular lines, the gradients are negative reciprocal of one another. And a knowledge box over here. If the gradient of a line is m, then the gradient of a perpendicular line is negative 1 over m. Let me highlight this negative, which is not so obvious. The product of the gradients of the two perpendicular line is negative 1, already done. Example 3. Now, this is the example that I want to focus. It says, find the equation of line B, which is perpendicular to this line. So y is equals to 5x minus 2. It's already in the gold standard form. Y is equals to mx plus c. Just grab the gradient from here. The gradient is 5. But this time we are talking about perpendicular line. So the gradient of the perpendicular line should be the negative reciprocal, which is minus 1/5. That thing is done. And rest is just the basic thing. It passes through this point 10, 4. It passes through the point 10, 4. So first of all, write down y is equals to negative 1/5 x plus c. Y, instead of y, write a 4. Instead of x, write a 10. So this is minus 1/5, 10 plus c. And go very easy. Go step by step. This is minus 2 plus c. Therefore, c comes out to be 4 plus 2, which comes out to be 6. Therefore, the equation is y is equals to minus 1/5 x plus 6. And that is the equation of the slide. Very, very basic. Coordinate geometry is a very, very important chapter. At the same time, it's very basic. Now, the basic idea, find the gradient of a line which is perpendicular to the line with gradient. So basically 6 will become negative 1/6. Negative 3 will become positive 1/3. Half will become negative 2. Negative 1 will become positive 1. The reciprocal of 1 is 1, and so on. 1.5, write in the standard form 3 over 2, and then it will become negative 2/3. That is the basic idea. Write down the equation of any line which is perpendicular to, let's say, let me pick this. So E is 2y is equals to 5x plus 1. Y is equals to 5 over 2x plus 1 over 2. The gradient of this line is 5 over 2. Now let's say there is a perpendicular line. So we are interested in the gradient. What have we studied so far? That the gradients are negative reciprocal. Remember the word negative reciprocal of one another. So flip it and this becomes 2/5. Change the sign. Since it was positive, this will become negative. And they're not just asking for the gradient, they are asking for equation of any line. Why? Because y-intercept could be anything. So since y-intercept could be anything, let me choose the y-intercept as 0. Doesn't make a difference. Y is equals to negative 2/5 x plus 0. That's a beautiful line. That's a line which is perpendicular to the given line. Someone can write y is equals to minus 2/5 x plus 70. Doesn't make a difference. The y-intercept could be very high. Someone could write y is equals to minus 2/5 x minus 1. And all these lines, they are what? They are perpendicular to the given line, and I have done part E. That is how you can do the rest of the parts. These are just concept building exercise. So I would like you to remember for this chapter the hashtag that is negative reciprocal. And I'm writing it in one go because that's how hashtags are written. Negative reciprocal, and let me write over here perpendicular. So for perpendicular, the rule is negative reciprocal. Make the following equations into pair of parallel lines. I mean, just write in the standard form and you will find it. Nothing special about it. For each of the following, find the equation of a line that is perpendicular to the given line. Let me highlight it. This is perpendicular to the given line and passes through the given point. Give answer in the form y is equals to mx plus c. So let me try out which part. Let me try out part this one, I. So in I, it's not in the standard form. 3y plus 8x is equals to 1. 3y is negative 8x plus 1. Y is negative 8x over 3 plus 1 over 3. First of all, what is the gradient of this line? That is negative 8 over 3. What should be the gradient of the perpendicular line? That should be negative reciprocal. Negative will become positive. 8 over 3 will flip and become 3 over 8. Through which line is it passing? 8, 7. It's passing through the line 8, 7. So let me write down y is equals to mx plus c. Y is equals to 3 over 8x plus c. Plug in x is 8 and y is 7. Y is 7, 3 over 8, and x is 8 plus c. So now do the cancellation. The 8 and the 8 cancels out. We are left with 3. Take it to the other side. Therefore, c comes out to be 4. 7 minus 3, that comes out to be 4. Therefore, the final answer, y is equals to 3 over 8x plus 4. And that is the equation of the line which is perpendicular to the given line and it passes through the given point. We have done part I. So that completes lecture number 3 of coordinate geometry, which is about parallel and perpendicular lines. So in the next lecture, we will be focusing on something related to midpoint and length of a line, distance between 2 points, and so on. Stay tuned for more at Mathematics with Shahab Yaqub.